All right, in the previous video, I kind of gave you a lot of background on this example here, and hopefully just to kind of work your head around what exactly is going on, what I now want to do is go through how to answer it far more quickly. So it says a new car is purchased for $52,000. It depreciates at a rate of 8% per annum, compounding monthly. Write a rule for the value of the car, C&N, after N months. We're depreciating 8% per annum, compounding monthly. What you need to understand is what this is a reducing balance depreciation, where each month I'm losing a certain percentage of the value. And I'm using the previous iteration's value when doing that. I'm not doing it in a flat rate way. It's always taking the value from the iteration before. This is what the recursion relation looks like. What we're doing is we're creating a general rule. So we're going to have to use this formula here. So let's come down here and write down that formula. It might get a little messy here because we don't have a lot of room, but let's try our best to fit it all in. You might have to write small. We're using C of n here as our notation. C of n is going to be equal to brackets 1 minus r over n over 100 raised to the power of n times by c of 0. All right, let's now zoom in here. My r value is my 8%. So I'm going to rewrite it now. 1 minus, in the r spot, I'm going to put my 8%. My n is the fact that it's monthly. So I put a 12 there. Then I divide it by 100. My n here, I'm going to leave this n because I'm creating a general rule, so I don't want to put anything in there, but it represents the amount of months. And then my c of 0 is the initial amount, which is 52,000. That is the initial amount of the car. If I now come to my calculator, and I'm specifically into my calculator, just going to be putting in this part here. I'm going to go 1 minus control divide 8 on 12. And then what I'm going to have to do is I'm going to have to divide just that part. Divide that by 100. And that's going to give me this, 0.9933. So that right there is 0.9933. All right. So that means what we have here is, if I was to write out my general rule now, which I'm doing, C, ooh, that's a funny looking C. C, what's happening? C of n is going to be equal to 0.9933, so that value right there, times by, oh, sorry, and I have to raise that to the power of n, as I do that, times by 52,000. That is what my general rule is going to be. And as you can see, I used the information that I was given here. So I took my rule that I was given up here, and I simply plugged in what I didn't know or what I knew for the r and the n and all of that. I got it. So that's what it is. Now, if you want the background information as to why that all works and why exactly we did certain things, like, for instance, why did we go 8 divided by 12? Well, it was because we went from the yearly to the monthly cost. Why did I go 1 minus it? The reason why I went 1 minus it is because it's the same thing as going 100% minus the percentage of the monthly loss. So this is how much it retains each month. Why did I divide it by 100? Because I needed to turn the percentage into a decimal. Why did I raise it to the power of n? The reason why I raised it to the power of n is because when we're dealing with recursion as opposed to the rule, as you can see here, when we figured out, after 3 recursions of it, you're just timesing that 0.9933 3 times. And that's why we can just raise it to the power of 3 there, or in the general rule, we're just raising it to the power of n where that represents it. So as you can see here, boiled down in our little rule there is a lot of information. And it's really important that you just don't kind of blindlessly use this rule. You need to understand each component of the rule in order to fully have a good foundational understanding of what exactly is going on there. There's a reason why I'm spending a lot of time on this stuff, and because it is important and you need to understand it and walk away with a really solid understanding of it. And the best place to get a good understanding is the very beginning. You don't want to be doing things 100 times. You want to get a good understanding from the very beginning. All right, let's pause here and go into the next part.